Students, today I am going to discuss about a comparative study between gravitation, electrostatic and magnetism. After this class, if you feel free, if you have any doubts on any numerical problems related to gravitation, electrostatic and magnetism, or maybe theoretical doubts, you can clear your doubt 24/7 in this number 9090700977. So let's start. So before going to start, let me discuss something. Basically in gravitation we are talking about gravitational force. In electrostatic we are talking about electrostatic force. In magnetism we are talking about magnetic force. So I am giving you a comparative study between gravitational force, electrostatic force, magnetic force. So let me draw a diagram. Let us consider two masses m1 and m2 separated by a distance r apart. So gravitational force of attraction between these two masses, let's say mass A and mass B, will be given as directly proportional to product of their masses. This is famous Newton's law of gravitation. So from Newton's law of gravitation, gravitational force of attraction between these two masses is directly proportional to product of their masses. Gravitational force of attraction between two masses is inversely proportional to square of distance of separation between them. So combiningly, F is proportional to m1 m2 by r square. So F is equal to G m1 m2 by r square. So basically, we have got Newton's law of gravitation like this. Now I'll move to electrostatic. So gravitational force depends on mass of the body and distance of separation between them. So what happened to electrostatic force? Electrostatic force was discovered by Coulomb, and he has given the law that is called Coulomb's law. Let us consider two charges Q1 and Q2. Let us consider two charges Q1 and Q2 separated by same distance apart r as we have considered in case of gravitation. Now electrostatic force of attraction or repulsion. So I have used gravitational force of attraction in case of gravitation, but in case of electrostatic I am using both attraction or repulsion. That I will discuss. So for the time being, you just concentrate that electrostatic force between two charges is directly proportional to product of the magnitude of the two charges. The two charges may be different, may be same in magnitude, may be opposite in nature. One may be positive, another may be positive. One may be positive, another may be negative. One may be negative, another may be negative. That I will discuss later. So force is directly proportional to the product of magnitude of two charges and inversely proportional to square of the distance of separation between them, just like your gravitational force. So F is proportional to Q1 Q2 by r square. Now F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by r square. So basically I have considered these two charges in a free space. For free space I am using 1 by 4 pi epsilon 0. Similarly, if I am considering a magnet, you know a magnet is having a north pole and a south pole, then let the distance between the two poles is r, then the magnetic force is directly proportional to product of the magnitude of the two pole strength. So I am taking Qm1 as the pole strength of north pole and Qm2 is the pole strength of south pole. Or for easy convenience I can write Qmn pole strength of north pole, Qms pole strength of south pole. Similarly, force is inversely proportional to square of distance of separation. So F is proportional to Qmn pole strength of south pole, pole strength of north pole, their product and square of distance of separation between the two poles. So combiningly, I will use a proportionality constant Qmn Qms by r square. So I got three different types of expression. Only thing similar between three forces are the unit of gravitational forces. Okay, I am writing gravitational forces is Fg. I'm writing electrostatic forces as Fe and I'm writing magnetic forces as Fm. So from these three equations, equation 1, equation 2, equation 3, from these three equations it is clear that the unit of all the forces are same, that is Newton in SI system and dyne in CGS system. But only difference is gravitational force depends on mass, electrostatic force depends on charge, and magnetic force depends on pole strength. So now I am going to discuss about pole strength. So pole strength is nothing but current and length between two poles. So basically pole strength is defined as the product of current and the distance of separation between the two poles, that is your Qm. But charge is a very fundamental quantity, but charge is not considered as fundamental quantity because charge Q equal to I T. I is current, T is time. So I can write like this: charge equal to current into time. So, but mass is a fundamental quantity. So dimensional formula of mass, unit of mass in SI system is kilogram, unit of charge in SI system is Coulomb, whereas unit of pole strength in SI system is ampere into meter. These are the units. This is the unit of mass in SI system, unit of charge in SI system, unit of pole strength in SI system. Now quickly I am going to write the dimensional formula of mass. So dimensional formula of mass is M1. In a stylish way I can write M1, L0, T0. Dimensional formula of charge. Dimensional formula of charge is, in your 11th standard you might have known the fundamental quantity is a current. So current possesses a dimensional formula A and time is T. So A1, T1, or else I can write M0, L0, T1, A1. This is the dimensional formula of charge. Similarly, dimensional formula of pole strength. Dimensional formula of pole strength will be, directly I am writing for current I am taking A and for length I am taking AL. So dimensional formula of pole strength I am writing here M0, L1, T0, A1. This is the dimensional formula of pole strength. Hope you have a very fair idea about gravitational force, electrostatic force and magnetic force. In my next video, I'll discuss further. I'll discuss about the units, dimensional formula of this. Okay, here G is called gravitational constant. Epsilon 0 is called permittivity of free space. Nu 0 is called permeability of free space. I'll discuss more in my next video. Bye bye.